Hi students, welcome to this course, PLC Automation, an introduction to programmable logic controller. I am Professor Yang. Analog PLC operation. Objectives. The keywords. Discrete and analog operation of a PLC. PLC analog inputs and output. The data flow and the number conversions. Input modules. Output module signals. Analog I/O operation. Objectives. At the end of this chapter, you will be able to differentiate it between discrete and analog operation of a PLC. This and define the various major types of PLC analog inputs and outputs. Describe the data flow and the number conversions involved in PLC analog operation. Convert input signals to a form usable by input modules. Convert output module signals to usable value for output devices. Describe the internal PLC operation for analog I/O operation. Program a PLC for use with both BCD and binary analog systems. Apply the analog PLC functions operation to industrial problem. Introduction. The keywords. To control any process with variables. Medium-sized and a large PLC. One analog input and one sensor. Position above. To control continuous process. Introduction. In this chapter, we consider analog PLC operation. Analog PLC control and be used to control any process with variables as a control consideration. Many medium-sized and large PLC are able to deal with analog signals as having discrete functions. For analog operation, the level of a PLC input signal is sensed by an analog input modules. And in addition, the level of the output can be a variable value sent to the process from an analog output module. PLC analog capabilities allow many different actions for one signal input depending on the input value. For example, a process in which 20 lights are used to indicate how full a tank is in 5% increments needs only one analog input and one sensor. A discrete system needs 20 on-off sensors and 20 inputs. Analog output programs have similar advantages. For example, A single analog output can position a valve in many different positions. Analog capability enables you to control continuous process in such industry as chemical and petroleum. Any number of variable input signals can be received by a PLC module and then processed mathematically by the CPU. The resulting analog value or values are then sent to an output module. The analog output module signal then controls a variable process or processes. Types of PLC analog modules and systems. The keywords: temperature, pressure, distance, position, or electrical values. Thermocouples, strain gauge, and straight electrical signal. The proportional integral derivative, PID. The electrical potentiometer. Straight numerical. Barcode readers and encoders. Analog PLC systems are of two general types, BCD and straight numerical. The BCD analog PLC system is sometimes called the multi-bit type. Figure 22.1 shows the operation of a sum wheel input to an input BCD module. BCD codes are fed into the PLC input module from the sum wheel output. Other possible BCD type inputs are barcode reader and encoder. In this case, BCD codes are fed from the output module to a numerical indicating devices. BCD output devices include such things as digital number displays, variable position actuators, and stepper motors. The other general PLC analog system is the straight numerical type. Some typical range of the modules available for this system are shown in Figure 22.2. The PLC numerical type modules is used for a large variety of input devices, the most common of which is the electrical potentiometer. The potentiometer is used to input a linear varying electrical value to the input modules. The potentiometer can be a type that reads temperature, pressure, distance, position, or electrical value. Other input include thermocouples, strain gauge, and straight electrical signals. The major complicated analog system, the proportional integral derivative, PID, output system will be discussed in Chapter 23. Note that the PLC handles continuous analog system in discrete steps. The continuous varying input signal is not strictly continuous when it reaches the PLC CPU. As we divide up the signal into more steps, it more nearly approaches the exact duplication of the input signal. Figure 22.3 shows how the input signal is divided into more parts for increased accuracy. As the number of the input divisions goes up from 8 to 16, the digital signal more nearly describes the actual input signal. Some normally used PLC divisions are 1024 and 1496. As the number of divisions goes up, the PLC cost also goes up. You must know enough steps to control your process with precision, but not so many that costs become prohibitive. This picture shows the analog BCD input and output systems. This picture shows typical analog I/O module ranges. This picture shows analog signal conversion to digital steps. This is the linear true analog signal. This is the 8-step AD converter board. This is 16-bit, 16 steps AD converter board. Homework: handwriting on keywords and submitting them to Coach Facebook. Just do the online quiz, and see you next time.